Hello po, ma'am. Marinig po. So, good morning, everyone. Good morning, Ma'am Brisa. Good morning, classmates. So, we are the Group 3, and we are going to report activity 12, preparation and standardization of HCl solution. So, our objectives is first, carefully perform the following procedures, and next, observe and record the data from the experiment, and C, solve what is asked and answer the given questions and analyze the whole experiment. So the materials we're going to use is first hydrochloric acid, next is the standard NaOH solution, and next is the phenolphthalein. So I'm going to give the floor to the next reporter.
So, preparation of hydrochloric solution. So first, pour around 50 ml of distilled water into 1 liter volumetric flask. Next is add 43.0 ml of hydrochloric cautiously and gradually shaking after addition. Third is mix well. Pour hydrochloric solution into a stack bottle. Fourth is label and preserve for future use. Note: solution should be standardized prior to use. Next slide, please. For the standardization of hydrochloric solution. First, from a Gessler burette, run down 20 ml of a prepared hydrochloric solution into a 250 ml Erlenmeyer flask. Second is add enough distilled water to make a volume to around 50 ml. Third is add 2 drops of phenolphthalein indicator. Fourth, titrate with NaOH using a more burette to a light pink color endpoint. Fifth is perform 2 determinations. Sixth, determine the normality of hydrochloric solution. Next slide, please. So question 1. Give the equation for the reaction involved during the titration. C1V1 is equals to C2V2. So C1V1 is equals to C2V2 is used to calculate an unknown quantity where two solutions or mixtures are proportional. So next po.
So here are the data that we have gathered in this experiment. So we have here two trials, which both use 20 ml of hydrochloric acid. During the titration, the initial reading of trial 1 was at 0 ml, and the final reading was at 11.8 ml. On the other hand, for trial 2, the initial reading was at 11.8 ml, and the final reading was at 26.5 ml. Therefore, trial 1 consumed or used 11.8 ml of sodium hydroxide, while trial 2 used 14.7 ml of sodium hydroxide.
marinig po ako. So, for the average normality, we got this result by adding the normality of trial 1. So for the trial 1, we have the 0.4918 MEQ. And for the trial 2, we have the 0.5137 MEQ. And divide it by 2 in order to get the final result with an average normality
Wait lang.
of...
Wait lang, Michaela. Wala akong marinig. Ako lang ba? Paki-fix daw. Baka ako lang.
Wait lang, ma'am.
Mahina lang, ma'am.
Yeah, mahina. I cannot hear yung sinasabi mo.
Okay na po, ma'am.
Mahina pa rin.
Ay, ma'am, wait lang. Manglipat na lang po ako ng phone, ma'am. Okay lang po.
Daw na sabtan sa mga giingon. Sige, fix mo na.
Hello, ma'am. Narinig po ako, ma'am. Okay na po.
Yes, okay na. Sige. Go.
Thank you. So for the average normality, we got this data result by adding the normality of the trial 1. So for the trial 1, we have the 0.4918 MEQ. And for the trial 2, we have 0.5137 MEQ. And divide it by 2 in order to get the final result with an average normality of 0.5028.
Ayan. May audible. So, sorry. So for the trial 1, we have here given C1 is equals to 0.5028 milliequivalent per ml. V1 is 11.8. We were going to find the C2, and for V2 is 20 ml. We will use the formula C1 times V1 is equals to C2 V2 to calculate an unknown quantity where the two solutions or mixtures are proportional. Next. So we have here, in order for us to calculate the C2 or the concentration of our final sample, we have here, we will substitute using our formula C1 times V1 is equals to C2 times V2. So our C1 is 0.5028 milliequivalents per ml times 11.8 ml is equals to C2 times 20 ml. Now we will going to crush out the ml, and we will be leaving with 5.93304 milliequivalent is equals to C2 times 20 ml. Now for us to cancel the 20 ml, we will be dividing both sides by 20 ml. So the C2 will be left behind and our answer will be 0.296652 milliequivalent per liter, or or in a simplified way 0.30 N.
So for the trial 2, we have the given, our C1 here is 0.5, 0.5028 MEQ per ml, and our volume 1 is 14.7 ml. Our volume 2 is 20 ml, and the unknown here is our C2. So our formula is C1 times V1 equals to C2 times V2. Next slide, please. Thank you. So to solve this is we have to substitute our data to the formula. So we have for our C1 is 0.5028 MEQ per ml times 14.7 ml is equals to C2 times 20 ml. So next is we have 7.39116 MEQ kasi maka-cancel yung ml ng C1 tsaka yung volume 1. It is equals to C2 times 20 ml. So we have to divide the both side by 20 ml. So maka-cancel yun siya. Ang may iwan na lang is 7.39116 MEQ over 20 ml is equals to C2. So the final answer is 0.369558 MEQ per ml, or 0.37, and which is our C2. Next slide, please.
So for analysis and conclusion, acid titration is a simple and fast method to determine the concentration of acid in a solution. The pH of the solution is measured by first adding a small amount of a known acid and then adding a small amount of a solution with an indicator. Acid-based chemistry is extensively used in the medical field in order to detect and analyze substances in blood and other body fluid. The most common method of detecting the presence of an acid or a base in a substance is to mix the substance with a chemical known as a reagent and observe the change in the color of the mixture. If the substance is an acid, the color will become more intense, and if the substance is a base, the color will become less intense and the mixture. Next slide, please. So that's all for our group, ma'am. Thank you.
Thank you. Ayusa. Ayusa, yan share.
Wait lang po, ma'am. Wait lang po.
Okay. So activity number 12 is preparation and standardization of our hydrochloric acid solution. So dalawang solution na yun ha. Number 1, sodium hydroxide. And in order for us to standardize our sodium hydroxide, we need a primary standard, which is the potassium hydrogen phthalate. Now, in this case, for activity number 12, to standardize the prepared hydrochloric acid, we used a secondary standard. So it's a solution with known concentration, actually coming from activity number 11. Ito kasi ginawa natin ng hydrochloric acid, it's a dilute hydrochloric acid. Kasi coming from the concentrated solution, remember, di ba, kumuha lang tayo ng concentrated hydrochloric solution doon sa fume hood, yung nagpo-fume pa na hydrochloric acid, it's a concentrated one. And then dinilute natin siya sa water. So that's a diluted solution of hydrochloric acid. And for us to know the concentration, then we did the titration process. Pero again, take note ha, secondary standard yung ang ginamit natin dito. Kasi solution siya, liquid siya with known concentration. That is coming from your output in activity number 11. I'd like to request control over your screen kindly. Ayan. Thank you. I want to control the screen para I can navigate this. This is the procedure first. And then, wala, sobraan ako. Wait lang. Procedure. Ayan. So, give the equation of the reaction involved in the titration. Saan yung equation niya? It's not the equation. This is the formula you have given here. Ay, masubraan dyan ako siya pindot. Wait lang. Ayaw pindutan din na ha. Pala sa... Ito pala yun. Yung pinagtaka ko bakit may C1B1 kanina. The equation na hinahanap dito is for the reaction at this one. This is the formula to be used for the computation. But the equation here is you have the HCl plus, ang ginamit ng titrant natin, NaOH. This is supposedly the equation. Ay, excuse my pen nga. Talaga control ang ano. Okay, so this will become NaCl plus HOH. So that's water. And this one is already balanced. 1, 2, 3, yeah, balanced. So this should be the answer for question number 1. The equation for the reaction involved during the titration. Ito yung formula na gagamitan natin for the problem solving. Okay? And then we this one is your data. So both trials use 20 ml of the prepared HCl. However, just like with the experiment number 12, we have a discrepancy here with the sodium hydroxide use. Pero hindi naman ganong malaki, so it's okay. 11.8 and 14.7. Average normality. Let me see again your computation. Trial number 1. Ano itong plus? Bakit may plus dyan? C1V1. Average na to. Nala ko. Saan trial number 1? Wala kayong nilagay na computer. Kanina, diba? Ito. Ito pala. Average pala yun. C1 is 0.5028. Ito yung ano ninyo, diba? Sodium hydroxide. Make sure that is your sodium hydroxide ha. Just get the average. Kasi dalawang trials din yung ating sodium hydroxide. So you just get the average and yan yung gagamitin niya here for the experiment number 12. And then ang nagamit is 11.8. Let me check. 0.5028 times 11.8 divided by 20. That's 0.2967. Okay, this is correct. Next, bakit iba ang normality dito? Ay, average normality pala yan. Bumalik ba? Ito yung trial 1. Wait, nalilito na ako. Nag-round off. Okay. Kaya pala may 30 and dyan. Nag-round off. Pero 0.2967. Okay. This is correct. Medyo confusing lang yung pag-type. Ito 0.5028 times 14.7 divided by 20, that's 0.3696. Okay, tama. Okay, so class, ang tandaan ninyo para hindi kayo malito, kapag direct titration using a primary standard, hindi ko ma-detect sa akong camera. Why is it? Wala siya. Oh, you cannot see me, ha? I don't know what's happening. Ay, ayan na. Ano ba? Okay, again. Kapag titration using a primary standard, you use the formula normality is equal to weight over volume times milli-equivalent weight or equivalent weight, ha? Kasi you have data there for the weight of the sample. But in this case, experiment number 12, that we use a secondary standard. So naka-solution yun, volume din siya. Wala tayong data for weight. Diretso na tayo, C1V1 equals C2V2. Si C1V1 is pertaining to the titrant used. Ang C is concentration, ang V is volume. And for the C2V2, that is for the analyte. So we are looking for the C2, the concentration of our analyte, and then the volume is yung volume na ginamit. So just like in the case of our experiment, 20 ml yung ginamit na volume. Okay? So any question for experiment number 12? I hope somehow you enjoyed doing the titration process, even if I think there are groups na I requested to repeat the procedure because of over titration. Pero again, I hope you enjoyed that one. Pwede next quiz.